So today in this class, I'm going to cover two theorems. The first one is parallel axis theorem. The second one is perpendicular axis theorem. So let us first start with the parallel axis theorem. Let me read its statement. It states that the moment of inertia of a plane section about any axis is parallel to the centroidal axis is equal to the moment of inertia of the section about the centroidal axis plus the product of the area of the section and the square of distance between the two axes. Okay, now if I explain you with the help of a diagram, let me draw a diagram here. Let there be a plane, y plane and x plane. And let us consider one irregular section of area A, and let x-axis run via its centroidal axis. Let this x-axis be its centroidal axis, G x-axis. Now in the statement, what it reads is that the moment of inertia of a plane section about any axis, it can be any axis, but the condition is that it should be parallel to the centroidal axis. This here x-axis here is the centroidal axis, and it should be parallel to this centroidal axis. So let us take another plane, and its axis is running parallel to our x-axis here, and let us name this plane as A B plane. Okay, and let the distance between these two axes be, the distance between these two axes from here to here be h. Now I want to find moment of inertia about IAB. Moment of inertia about IAB. This IAB is any plane which is running. IAB is any plane which is running parallel to this centroidal axis, x-axis of this irregular plane, right? So if I want to find the moment of inertia about this IAB, my moment of inertia will be equal to the moment of inertia of this irregular plane, which is moment of inertia of this irregular plane area will be I x plus the area of that irregular section into the distance between these two planes. The distance between these two planes is h, so into its distance and squared. So this is your simple explanation for parallel axis theorem from the statement. Now what is Ixx here? Ixx here is the moment of inertia of the centroidal axis of this irregular section, right? Ixx here is moment of inertia of the irregular section about its centroidal axis, x-axis. Okay, now what is A? A is the area of the irregular plane. Right? Now what is my h? H here is the perpendicular distance between the two axes. what is the two axes here? Axis xx axis and axis AB axis. Okay. Now similarly, if I want to find moment of inertia about IYY, let us draw the plane first, right? Y plane here, and this is X plane here, and again there is one irregular section of area A, and this time its centroidal axis is running via YY axis, Y axis, and let this be the centroid G. Now let there be any plane and this plane's axis is running parallel with this YY axis. So there is a plane and its axis is running parallel to this Y axis here, and let us name this axis as AB axis. Now similarly, I want to find moment of inertia about this plane IAB, and the distance between these two axes be h again. Okay, so what will be my moment of inertia about this plane IAB? It will be equal to the moment of inertia of this irregular axis which is running via its centroidal axis IYY plus area of this irregular section A into the distance between these two plane, and square. This will be your moment of inertia about YY axis. So what is IYY here? It is moment of inertia about its centroidal axis, YY axis, right? And what is my A again here? Area of the irregular section. Right? And what is my H? H is the perpendicular distance between the two axes. Okay, so this is the simple meaning of the statement and the simple explanation to understand the parallel axis theorem. I hope it is clear. Now the second theorem is perpendicular axis theorem, and let me read its statement again. It states that if Ixx and Iyy are the moments of inertia of a plane section about the two mutually perpendicular axes meeting at O, then the moment of inertia about Izz, about the third axis zz perpendicular to the plane and passing through the intersection of xx and yy, is given by Izz equals to Ixx plus Iyy. Again, this is a very simple explanation of perpendicular axis theorem. If I explain it with the help of a diagram, let me draw the planes first. Okay, right? Let this be my y plane and let this be my x plane, and let this be my third plane, which is the z plane. Let me consider one irregular section again, and let this be point of intersection be O. Right? Now, what does the statement state? It states that if Ixx and Iyy are the moments of inertia of a plane section about the two mutually perpendicular axes. It is perpendicular to each other, y and x, they are perpendicular to each other, meeting at O, and it is meeting at this point O. Then the moment of inertia of the third axis, which is this z axis. This third axis is the z axis, and this moment of inertia about this third axis, which is again perpendicular to the plane and passing from this intersection passing through this intersection O, which is passing through for both y as well as x axis, is equal to Izz is equal to Ixx plus Iyy. So in simple term, if I want to find the moment of inertia about this third axis Izz, I simply need to do the addition of this moment of inertia of these two planes, which is x axis and y axis, and I get the moment of inertia for the third plane, which is z plane. I hope it is clear. Now this Izz, this third axis Izz, is also known as polar axis. It is also known as polar axis. Izz is also known as polar axis, and it is denoted by IP. So my Izz is equals to polar axis is equals to IP. Okay, and this theorem, this perpendicular axis theorem, is also known as polar axis theorem. The moment of inertia of Izz about the axis ZZ is called as polar moment of inertia, and it is denoted by IP. Okay, so I can also write this statement as, since my Izz is equals to IP, I can also write that Ixx plus Iyy. So I can also write it in this manner. Okay. So let us see the polar moment of inertia of a different section. Polar moment of inertia of different sections. Okay, now let us first see the polar moment of inertia for a solid circular section. I have a solid circular section. Okay, let us say that Yy is running from this plane, Ixx is running from this plane, y, x. Now from the previous video, how do you find the moment of inertia of a solid circular section? That my moment of inertia about Ixx axis is equals to Iyy axis is equal to pi by 64 d raised to power 4, right? So this was the moment of inertia of my solid circular section. Now if I want to find the polar moment of inertia or polar moment of inertia of this circular section, which is IP of the circular section, it will be equal to Ixx plus Iyy. So what is my Ixx? Ixx is pi by 64 d raised to power 4 plus pi by 64 d raised to power 4. Now from here, what do we get? Since my pi by 64 is pi by 64 into d raised to power 4 plus pi by 64 into d raised to power 4. It is 2 times. So I can simply write 2 times pi by 64 d raised to power 4, or you can simply do the find the LCM and you can add it up also, but I'm doing it in a simple manner. So 2 32 the 64. So what do I have? Finally I have pi by 32 d raised to power 4. So this is my polar moment of inertia for a circular section. So my IP is equal to pi by 32 d raised to power 4. So this is my polar moment of inertia for a circular section. Now if I see polar moment of inertia for a hollow circular section, IP for hollow circular section, what is it gonna be? Let's draw the hollow circular section. It's going little random, but I hope you understand it. This is my centroid G. Let this be y-axis. Let this be my y-axis, x-axis. Okay. Now, what is the how do I find moment of inertia about Ixx of a hollow circular section? Ixx is equal to Iyy is equal to pi by 64 d raised to power 4 minus small d raised to power 4, right? So my polar moment of inertia IP will be equal to Ixx plus Iyy, which will be equal to pi by 64 d raised to power 4 minus small d raised to power 4 plus pi by 64 d raised to power 4 minus small d raised to power 4. So it is 2 times pi by 64 d raised to power 4 minus small d raised to power 4. So again I cancel 32. So my polar moment of inertia for my hollow circular section IP is equals to pi by 32 d raised to power 4 minus small d raised to power 4. So this is my polar moment of inertia for the hollow circular section. So I hope perpendicular axis theorem is also clear to you. Perpendicular axis theorem is also known as polar moment of inertia, and it is denoted by IP, or we can also say that if we find the moment of inertia about the third plane, which is the z plane here, then that moment of inertia is known as a polar moment of inertia, and we can find it by adding up the moment of inertia of the two planes, that is, and those two planes are x plane and y plane. I hope it is clear to you now. Now let us do some simple numericals. Let us read the question. It says a square has a side 120 mm. Calculate moment of inertia about A. Vertical centroidal axis, B. the base. From the question it is clear that the geometrical section that is given is a square. So let us draw a square first. A square. So if this is B, my B will be equal to 120 mm. If this is D, this will also be 120 mm since it's a square. Now let us say that two axes, let's say this is y-axis and this is x-axis. Y-axis here and x-axis here. So let this be the centroid G. Now what do we need to find? We need to find first condition, first one A. We need to find moment of inertia about the vertical centroidal axis. Now what is the vertical axis here? The vertical axis here is I, Y, Y. I, Y, Y is your vertical centroidal axis in the diagram. And what will be I, Y, Y? Moment of inertia for a square section. It will be equal to dB cube by 12, right? So how much is my D? D will be equal to 120, B is 120 again, cube by 12, right? So how much will we get this from here? Let us do the simple calculation, right? So here it is equal to how much is 120 into 120 cube. So let us do 3 times. 120 into 120 into 120. So that is 120 cube divided by 12. So I'm getting 1728000. So let us convert this and make it into, how much are we getting? We are getting 1728. Now that 4 zeros, let us convert it in terms of 10 power. It will be 10 raised to power 4, and its unit of moment of inertia is mm raised to power 4. So this is your first answer, moment of inertia about the vertical centroidal axis. Okay, now B. In B, you are asked to find moment of inertia about the base, right? So if we name this, if we name this square as, let this be A, B, C and D. So from here my base will be AB. So if I want to find moment of inertia about base AB, my base AB, which is I, A, B, will be equal to, now which theorem do we use in here? Now we have to find moment of inertia about the base IAB. Now IAB is running parallel with this XX axis here. So which theorem do we use? The first theorem, parallel axis theorem, right? So in parallel axis theorem, the theorem formula for the theorem is IAB equals to IXX YIXX, because IAB is running parallel with XX axis plus area of this whole square, into its distance squared. Now what will be the distance from AB to what will be the distance of this axis AB to XX axis? It will be this distance h, right? So let us find out. My IXX will be equal to BD cube by 12 plus area of the square is side square, so I have side square as 120 into 120, right, into what is my height? Since it is a square and the axis is running from in between the section, so my height here is equal to its depth d divided by 2, right? So my height here is d divided by 2, its whole square, right? So what do I get? I'll further get equals to, my b is again 120 into 120, d is 120 cube by 12 plus 120 square into, how much is my d? D is 120 divided by 2 square. So what do I get from here? I have the same equation here as IYY, so let us write this as 1728 into 10 raised to power 4, right, plus 120 square into, this will be 60 square. So what do we get? Let us do in the calculator. Right, let us first do the AH square part. 120 into 120 is my area of the square into 60 square, 60 into 60. I get this much. This is just the part of area into its distance h, perpendicular distance h, plus what is the moment of inertia about IXX axis? It is 17280000, right? So what am I getting? I'm getting 69120000. So how can I write this one? I can write this one as 6912 into 10 raised to power 4 mm raised to power 4. So this is your moment of inertia about the axis IAB